Hi, this is Dan Wiebe, and this video is the first episode of Testing Tools for Mask. Today we're going to mostly be talking about TNT, and our audience for this video is first of all people who have time to volunteer. And by that I mean, seriously, if what you're interested in is just trying out the software to see how it works, or satisfying your own curiosity about it, you're certainly welcome to listen to or watch the rest of the video. But this isn't really oriented toward you. This is toward people who actually want to be part of the Mask team and contribute to the work that goes into Mask. Also, we need you to be willing to use the command line. If you're afraid of the command line, that's okay, as long as you're willing to work through that fear. It's not that terribly difficult. But if you're testing Mask, you're not going to be doing a lot with graphical user interfaces, at least not for the foreseeable future. We would also like people who are not Mask developers. If you're a developer, that's fine. We just don't want you to be a Mask developer if you're a tester, because probably the correct term is not quite conflict of interest, but if you're thinking about Mask from the viewpoint of a developer, then it's going to be harder for you to think about it from the viewpoint of a tester. If you develop something else, on the side, or maybe for your main job or whatever, that's fine. That's fine. You can still think about Mask as a tester. If you're not a developer at all, that's, at least from some perspectives, even better. Because you won't even be tempted to think about Mask as a developer. We specifically need people who can think like users, and people who can think like attackers. Because developers, we developers, we try to think like users, we try to think like attackers. We're not. Those impressions or those efforts are contaminated by the fact that we're developers. It's good to have people who are uncontaminated by the knowledge of exactly how it works, so that those people can try out things like, does it work this way? Does it work that way? How about this thing that he never thought of? Those are the sorts of people that we would like to use as testers. Also, right now, this particular tool that we're talking about, TNT, it doesn't work on Windows. So you'll need to use a Linux machine or a Mac machine to use it. And you don't want a really small one. I talked to one fellow who said that he had a Windows machine. His main machine was a Windows machine, but he was going to do whatever he could to help. And what he was thinking was he'd run TNT on his Raspberry Pi, which was a Linux machine, and do it that way. Well, a Raspberry Pi just doesn't really have the power to test several nodes at once. And so Raspberry Pi is not big enough. An average Linux or Mac laptop, maybe it's big enough, maybe it's not, but Raspberry Pi isn't. A desktop machine with 32 or 64 gigabytes of memory, and it is fine. Mostly what we want is memory. We haven't really looked for minimums, but I would say probably if you have less than 8 gigabytes of memory, might be a little hard. But that's just a guess. Also, the people who work as testers, we want them to be willing to indulge a certain amount of formality. We have processes mostly in place. We still need to complete the definition of those processes. But we do have processes that will ensure that when a card actually goes into production, into the production branch, it'll have somebody's name on it that says, I certify that, this card works the way it's supposed to. If you're not willing to be that much a part of the team, again, you're welcome to watch and enjoy the rest of the video if you want. But mostly, we're after people who are interested in leaving their mark on Mask. Okay, so what is this TNT thing that we keep talking about? The first thing that might be puzzling about it, I think, is that sometimes it's called cluster tool, and sometimes it's called TNT. What's that all about? Well, back when masq was forked from Substratum's node, we knew that we knew that Substratum node was a trademark that we couldn't, I mean, for legal reasons, we couldn't keep that name, so we had to come up with our own name, which we did, masq. But we didn't know whether there was a trademark on TNT or not. Or the TNT stands for testnet tools. I don't think I've said that before. We didn't know, so we decided that we might rebrand that as well. And so we started just by calling it cluster tool. And I think the only thing that's called cluster tool about it right now is the repo name, the GitHub repo name. There may be a couple of other things, but mostly it's called cluster tool in the GitHub repo name. But it turned out that wasn't really an official trademark. There's nothing wrong with just continuing to call it TNT, which is, what everybody knows it by anyway. So eventually we're going to change the cluster tool, all the cluster tool references back to TNT, but we haven't gotten around to it yet. So you'll see it called both things, but they're both the same. I mean, they're two different terms for the same thing, and cluster tool is deprecated. So we're here in this video. After we finish with this item that's showing on the screen right now, we're just going to call it TNT and not cluster tool anymore. So TNT is only intended for testing. It's almost useless for production. Once you hear what it does, you may think to yourself, oh, this is interesting. If I want to run a stable of nodes so I can make a bunch of money, then I should do it with TNT. And I would discourage that just because TNT isn't really oriented in that direction, and it's liable to have enough functionality to get you into trouble and not enough functionality to get you out. You're welcome to try it if you want. I certainly can't keep you from doing it. But what we really ought to do, if that becomes, running a stable of nodes is a thing that lots of people want to do, there ought to be a separate tool for that. It may use some of the same code that TNT uses, but it should be a separate tool. So TNT is a tool for starting and monitoring multiple nodes. It it starts them the way you tell it to start them, and connects them the way you tell it to connect them, or a default way if you don't tell it, and then just watches them run. It can do this in a number of environments. For example, it can do it. It can start nodes on virtual machines in Amazon Web Services or in the Google Cloud. If you have leased virtual machines that are running there, that takes a little money. So since masq is not a funded project at the moment, I don't believe masq actually has any owns any leased virtual machines either in AWS or in Google's cloud. However, it can also run nodes in VirtualBox virtual machines. VirtualBox, if in case you don't know, is a virtual machine hypervisor that can run right on your desktop or laptop and start up any number, subject to memory constraints, of virtual machines on your system, and each one of those virtual machines can run a node. But that's really not what we're going to talk about here, or that's not what we're going to be mostly using it for, because we're going to be using Mac and Linux to run it with Docker. If you don't know what Docker is, that might be something to go pursue. I won't say much about it here, except that it's kind of like VirtualBox in a way, except that it's more limited to VirtualBox. It can only run operating the quote virtual machines unquote that it starts. Can only run the same kernel, the same operating system kernel that your main operating system is running. But in being limited that way, they're also much faster and much less resource intensive than VirtualBox virtual machines. They're called Docker containers, not virtual machines containers. Docker is perfect for what TNT needs to do. So how does TNT work? Well, as a user or a tester, you're going to start up TNT, which is a Python program. And when you direct it to, TNT will start up some number of nodes that's specified by you. It can be anywhere from one node to dozens of nodes. And these nodes are called node 0, or node dash 0, node dash 1, node dash 2, up to node dash 24 or node dash 57 or whatever it is. And those nodes, once they come up, of course, each one of those nodes will start its own log. And if you leave them alone and you let them start up the way they want to, they'll start that log in trace mode. So the logs get pretty big pretty fast. And then TNT will suck in information from all those logs and use that information to generate reports and graphs for the user, and also just let the user look at the logs. And so you can tell what's going on in the nodes. You can see each node's view of the situation, and just tell what's going on and whether your test is passing or failing. So what's the present condition of TNT? It is definitely test harness code and not production code. So it's not designed to be. It's not designed for its UX. It has a. I don't mean that to sound like it's shoddy, because it's not shoddy. The UX is certainly approachable and it's informative, but it's not the sort of UX that you're used to seeing in command line programs. It takes a little bit of getting used to, but of course, once you get used to it, it's pretty quick and easy to use. It's pretty configurable. It could be a little more configurable, and there will probably be cards to make it more configurable, and some of those cards will no doubt be generated by testers like you, and run by developers probably like me, and then tested by testers like you. But right now it's what do I want to say? It's capable of doing the stuff that it needs to be able to do, perhaps with one exception. That there's a card already for, but the card hasn't been played yet. It is test-driven. There are tests for TNT. You can, once you have TNT downloaded, you can type ci/all.sh, and the tests will run, and you'll see whether they all pass or whether some of them fail. And any future changes to TNT will also be test driven. It is potentially Windows compatible. There's nothing that we're doing in TNT that is just absolutely impossible in Windows. But when we wrote TNT back in Substratum, when Substratum wrote TNT, we really didn't have any Windows development machines. And so we never really made it Windows compatible. There's nothing that says that it can't be Windows compatible. It just isn't. And Windows compatibility may be a direction that we decide to go in the future if it turns out that we can't get enough testers to do what we want to do in Linux and Mac. But here's a whole, here we get 24 more testers if we can make it Windows compatible. That would probably be enough to bump up the priority of that to a place where it would actually get done. But right now it's not Windows compatible, so you have to do it in Mac or in Mac OS or Linux. Also, it's about 85% operational. By that I mean that there's functionality in it that, how do I want to say this? When the functionality was put in, it worked just fine. But since then, it hasn't been used. And so probably it doesn't quite, the system has changed underneath it, but nobody's needed to use that functionality because that testing functionality was used to get the system over a hump that it is now over, and it doesn't have to go over that hump again. And so nobody's used that functionality, and so it sort of has decayed and doesn't quite work anymore. I don't think that will turn out to be a problem. in the future, but if it is, it can certainly be fixed. So, like I said, this is test harness code. It's not production code. It's not meant for, it's not meant for people to bang on and try to attack and destroy and so on. It's meant to be used as a method to try to attack and destroy the node. So that's the intended production software. So that's a picture of what TNT is and how it's used and how it operates. We'll get into examples next. Okay, so the first thing to do is to go to GitHub and look at the masq.project, and you'll see our front page. If you scroll down, you see three repos. This is the actual node code. This is the Ethereum contract for the sub token, which I don't expect will get much activity, but we're interested in cluster tool, so click here. And you get the cluster tool repo. You'll notice that here is the code. Here are the setup instructions, which are going to be important, but not right this instant. But the important thing for right now is this clone or download button here. You want to click that. You want to make sure this says clone with HTTPS. Which is a good thing, and you want to get this string here on the clipboard, either with Command or Control C, like this, or you can click this button, in which case it goes onto the clipboard as well. That's the important thing here. For the next step, you will need Git installed on your system. If you don't have that, go figure out how to do that and come back. All right, the next step is to find a directory under which you want to install TNT and navigate there. I'm using this directory because I already have TNT installed in the system, of course, but I'm going to reinstall it here under this masq video directory. There is nothing in this directory right now. What you want to do is type git clone. This is, of course, assuming that you have Git working on your system, and then paste that URL that you got from GitHub, and hit enter. And now, if I do an ls, you'll notice there's a cluster tool directory. If you like, you don't have to, but if you like, you can rename cluster tool to TNT. And if we cd in there and look, there's the TNT code. So this is a good place to start following the instructions from the README file on GitHub. So let me figure out how I'm going to do that in the screencast video. Here are the instructions for installing TNT. You'll notice here that you're going to need Python on your system, version 2.7 point something, basically not version 3, version 2 point latest, which is 2.7 point. I'm not sure what the actual latest is, but it's not right now. It's not compatible with Python 3, so don't install Python 3. Probably you already have Python 2 installed on your Linux or Mac machine. To find out, just go to a command prompt and type Python, and if you get an error message that says Python isn't installed, then you need to go figure out how to install Python. If you do have Python installed, it'll put you in a REPL that you can get out of, I think you type exit with parentheses or something like that. If you try to get out and you can't, it'll tell you how to get out. This part here about SSH, we don't really need that to use Docker. Probably you already have SSH installed on your machine again, but we're going to use Docker, and so we won't really need SSH, so I don't really care whether it's installed on your machine. Here This is definitely required. We do have to install a bunch of Python dependencies. I'm not sure that I'm going to get much out of this on my machine because, like I said, I already have Python installed on my machine, but let's see how it goes. Okay, so back in the command window, let's do a CI setup. And oops, it looks like I don't have pip installed. Pip is a package manager for Python. Let's install that. Okay, let's try CI setup again. And there, I've got the requirements installed. Let's go back to the README and see what's next. Okay, so it looks like the next thing to do is to install, oops, didn't mean to do that. Next thing to do is to install GraphViz, which is the thing that makes the graphs of the neighborhood. It's probably going to look a little bit different on the Mac. You might use Homebrew to install it on a Mac. I don't really know. I don't have a Mac, but it should be fairly easy to go to the GraphViz website and figure out how to install it on your Mac. So let's go do that. Like this. And there's GraphViz. Cool. Let's go look at the next step. Okay, this particular piece of instruction here is, this is kind of misplaced. We don't care about this until later. So here is, this here is mostly concerned with if you're going to run TNT using Amazon Web Services or the Google Cloud. Which we're not here. That might be for episode 2 or episode 3. But just so you understand where this came from, when TNT was first developed, it only worked with Amazon Web Services. Then Google Cloud was added to it later. Then Docker was added to it, and then VirtualBox was added to it. So at the beginning, it worked with paid cloud services. And of course, if you use paid cloud services, then there are secret keys and stuff that you have to use to connect to them that you pay for. And what this TNT config thing is, it's the file that holds your secret keys. So TNT config, of course, is not distributed with TNT because we can't tell what your secret keys are. So we can't distribute this file. However, we distribute this file, which, if you look at it, is a version of TNT config that's empty, that doesn't have any secret keys in it. So what you do is take this empty version and you copy it to here so that you actually do have a TNT config.py. And then if you were going to use cloud services, you'd go in there and fill it out with the various secret keys and stuff from your cloud services, and you would absolutely not ever upload that to anywhere public because, again, it contains your secrets that you don't want to share with the world. So you just keep that on your machine and don't ever share it with anybody. Now, for episode 1 here, we're just going to be using Docker, so we won't have any secrets to worry about, and our setup will be pretty simple. We're just going to do this copy, and we're going to forget about this because it doesn't apply to us just using Docker. So here we'll just type cp like this. Now we have a tnt.config or tntconfig.py, and that's all we need for that step. Okay, this next step is only for people who are running on the Mac. It turns out that TNT needs to control your terminal window in order to be able to execute commands in your terminal window on the nodes that that TNT is in the herd that TNT shepherds. And the default terminal that comes with macOS doesn't allow doing that. A lot of people have iTerm installed just because iTerm is a bigger, better terminal that has more capabilities than the default terminal program, terminal application. So TNT needs iTerm. If you don't have iTerm installed, then you should install iTerm before you try using TNT. TNT will just use iTerm if it's installed. If it's not installed, I don't know whether TNT will crash or whether it just won't let you do the stuff that it probably will crash. That's my guess. So again, if you have a Mac, make sure you have TNT or make sure you have iTerm installed. Probably if you're a Power Mac user, you already have it, but if you don't, just install it. These next few sections, we're not going to use it with Google Cloud here, or at least not in episode 1. But if you want to set it up in Google Cloud, you'll want to take a look at this. If you want to use it with Amazon Web Services, take a look at this. Want to use it with VirtualBox here. To use it with Docker, which we do, we have to build the Docker image. If you're not familiar with Docker, of course, in order to do this, you'll have to have Docker set up on your system. That's not a particularly trivial thing to do. You'll want to, there's a different way to set it up on Linux and on Mac. If you don't have it set up, you do want to set it up, and you want to set it up so that your user is a member of the Docker group. The reason you want to do that is because the Docker group will have special privileges so that you can type Docker commands without running sudo. TNT will not use sudo to run Docker commands. Therefore, if your user is not a member of the Docker group, TNT won't work for you. So that making yourself a member of the Docker group, the Docker installation instructions will make that kind of optional. Because Docker will work without it. You just have to, all your Docker commands have to have sudo on them. But TNT doesn't do that. So for TNT, that membership in the group is not optional, it's required, which means that after you install Docker, you will most probably have to at least log out and log in again. You might even have to reboot your system. So do that. And then we'll go and see about running this setup Docker thing to create the image from which the containers will be spawned. So we'll run CI setup Docker here. We're downloading the image from probably Docker Hub. So that should do it. Now let's see if the tests pass. And they do. So Docker is installed, and I'm sorry, TNT is installed, and its tests pass.